Bonjour à toutes et à tous. Donc, bienvenue dans cette troisième édition des MIAI-Days. C'est l'événement annuel de notre institut qui s'étale sur plusieurs jours et qui vise un peu à présenter, faire un bilan de notre activité, un bilan annuel et puis un bilan un peu depuis le début en ce qui concerne cette troisième édition. Voilà, donc on a un programme un peu chargé, j'y reviendrai tout à l'heure, mais je voudrais tout d'abord passer la parole à Yassine Lakhnech, qui est président de l'Université Grenoble-Alpes et qui nous a fait le plaisir d'être présent parmi nous ce matin. Je tiens vraiment à le remercier. L'Université Grenoble-Alpes, c'est l'établissement qui porte MIAI. Et puis depuis le début, donc l'UGA et Yassine ont été à nos côtés, et puis ont même travaillé avec nous pour le montage de cet institut. Yassine, je te laisse la parole.
Bonjour à toutes et à tous, je ne suis pas sûr que j'ai besoin du micro. Je vous remercie de l'invitation d'abord. Donc les moments sont rares où je suis dans ma communauté scientifique, donc j'essaie d'en profiter un petit peu. Bon, ce que je voulais dire, mais je vais être très très court. Donc tout d'abord, je pense que MIAI pour nous est un exemple en termes de fonctionnement. Pourquoi c'est un exemple? Alors il y a plusieurs raisons pour ça. Alors d'abord, je trouve que en termes de construction interdisciplinaire, les différents sujets qui sont abordés, en termes de fonctionnement, c'est un exemple que d'ailleurs on essaie de dupliquer dans d'autres domaines, je pourrais vous en parler. C'est aussi un exemple parce qu'on a vraiment une communauté où la réflexion elle est vraiment de manière intégrée sur les aspects formation, recherche et les aspects valorisation. Un écosystème, si je peux utiliser ce mot-là, qui s'organise, autorégule. C'est rare que des problèmes ne me remontent pas, mais MIAI pratiquement jamais, donc je dis ça fonctionne très bien. C'est parfait. C'est de la très bonne science qui se fait dans MIAI. Et puis aussi, tout ça est reconnu, puisque je me réjouis en tout cas personnellement beaucoup pour les succès obtenus, pour la confirmation du statut 3IA, d'avoir obtenu le budget total qui a été demandé. Je pense que l'évaluation a été très positive et donc c'est parfait par rapport à ça. Il y a aussi les succès côté formation. Je ne sais pas si Jean-Louis est là. Donc sur l'appel à manifestation d'intérêt et compétences métiers d'avenir, où pareil, le projet a été, je crois d'ailleurs, a été accepté en fast track. Il a été, j'ai vu les évaluations et les scores qui étaient formidables. Donc ça confirme un petit peu aussi le projet en termes de formation. Et donc tout ça, et la dynamique partenariale, il y a plus de 50, presque 60 entreprises qui sont impliquées dans MIAI, c'est très important par rapport à ça. Maintenant, la question, c'est l'avenir. Je pense qu'il faut construire sur ce qui a été fait, mais d'une certaine manière, ce que je discutais avec Eric juste avant, autour du café, il faut se projeter, à mon sens, en tout cas moi je serai preneur de vos réflexions et de votre projection au-delà des 3 années qui viennent, vraiment sur plus tard, en termes d'orientation scientifique par rapport à ça. On a abordé quelques sujets, en tout cas je serai preneur personnellement de voir votre vision en termes de questions en lien avec l'IA et les aspects écologiques, l'IA frugale, la question, mais qui est probablement beaucoup trop, pour l'instant, qu'il faut peut-être aborder pour mieux comprendre le sujet, les questions de l'IA et le quantique. Il y a aussi les questions d'hybridation de l'IA avec d'autres méthodes et d'autres techniques, comme la simulation numérique ou autre. On a une proposition d'une CPJ, typiquement, par exemple, par rapport à ça. En tout cas, je serais preneur d'avoir vos réflexions sur une projection d'ici 10 ans, par exemple, sur quels sont les projets, en tout cas les orientations pour l'IA à Grenoble. Ce que je disais à Eric, c'est qu'il y avait une période à Grenoble où il y avait beaucoup d'émulation, stimulation, etc. autour de l'informatique, numérique de manière générale. C'était une période où il y avait des travaux sur la compilation. Vous savez que peut-être... des réflexions sur compilation à Grenoble. Il y avait en même temps des réflexions sur le model checking, sur l'interprétation abstraite et l'analyse statique, sur d'autres sujets, etc. Et c'était un moment qui était très, très enrichissant pour les laboratoires, pour les équipes, pour les personnes, et puis un moment de temps qui a duré plusieurs années. Je pense que peut-être que ça serait utile d'avoir une réflexion, mais je pensais à vous de la mener, de faire des propositions par rapport aux grandes orientations en lien avec l'IA par rapport à ça. Par exemple, la question, mais il y a déjà des chaires là-dessus, sur l'intégration d'autres contraintes au moment de la conception des systèmes d'intelligence artificielle, des contraintes qui peuvent être des contraintes physiques liées à des aspects énergétiques, mais aussi des contraintes réglementaires, etc. En tout cas, de l'IA prouvably fair, prouvably frugal, etc., etc. C'est des sujets, à mon avis, en tout cas, qui pourraient être intéressants par rapport à ça. Donc voilà, donc l'IA est un des domaines phares de l'Université Grenoble-Alpes, puisque c'est grâce à vous, hein, donc, puisqu'il y a en termes de travaux, en termes de sciences, mais aussi en termes des appels à projets et puis des orientations de France 2030. À côté de l'IA, il y a le quantique, justement, où Grenoble et parmi les sites, l'UGA et parmi les universités, 2-3 universités en France qui portent ce thème-là. Et l'UGA porte le seul projet national côté formation. C'est un projet de 57 millions d'euros qui implique 21 universités et on n'est pas l'UGA. Pareil pour la cybersécurité, l'hydrogène, batterie, microélectronique, etc. Et l'IA en fait partie, donc ça fait partie de la signature de Grenoble par rapport à ça. Mais il ne faut jamais se contenter de ça. Vraiment, moi, je suis preneur de vos réflexions sur l'IA à Grenoble d'ici 10 ans, 15 ans. Merci.
Merci beaucoup, Yassine. OK, donc je vous propose qu'on passe à la suite. Alors, je voudrais rappeler peut-être très rapidement le programme de ces quelques jours. Donc, on a après une brève présentation de notre institut, je passerai la parole à Claude Castelluccia et Alexis Léautier qui vont parler d'intelligence artificielle et de vie privée. Et puis ensuite, on aura une session qui sera dédiée à IA et société ce matin, puis cet après-midi, une session qui sera dédiée à l'IA et l'éducation. Ce soir, il y a un temps de présentation des doctorantes et des doctorants de MIAI, un temps court, en fait, pardon, court pour chaque doctorante, chaque doctorant, mais un temps d'1 heure à peu près. Et puis, il y aura un jury et des prix qui seront remis aux meilleures présentations ce soir, donc de 17h à 18h. Demain, il y aura 2 temps forts, un temps sur l'IA et l'énergie et l'environnement, et on parlera aussi d'IA frugale à ce moment-là, et de transition écologique. Et puis, un temps qui sera dédié plus aux problématiques cœur de l'IA, qui sont des thématiques importantes et qui se retrouvent dans tous les instituts d'IA. Et puis, nous terminerons la journée par une session IA et art qui sera réalisée par Magali de Bazeille, qui est parmi nous aujourd'hui, que je salue au passage. Et puis enfin, mercredi matin, nous aurons un temps sur l'innovation, et puis encore une session de présentation de doctorantes et doctorants. Donc vous voyez, on va retrouver un peu les 3 piliers de notre institut, la recherche, l'éducation, la formation et puis l'innovation. Voilà. Donc ce que je vais faire là, c'est que je vais passer directement à une petite présentation que je vais donner en anglais pour les gens qui sont connectés, puis que je vais essayer de faire rapidement. Pas forcément toujours très intéressant ces présentations, mais pour vous donner un petit peu une image des réalisations que nous avons tous faites par les membres de MIAI depuis 3 ans maintenant, un peu plus de 3 ans. Okay, so MIAI aims to be the place where to do research, both applied and fundamental on AI, to do technology transfer on AI, to do innovation on AI, and to do training on AI. And so we right from the beginning, Yassine told me we should be as open as possible. We should be the place to be in Grenoble where to do AI. Okay, I think I can use this one. So you see that we have a certain number of industrial partners. On this slide, you have all the academic partners. And as I mentioned, UGA is the partner that is managing this project. And there are a lot of industrial partners, now around 89 private industrial companies, and they contribute with a bit less than 4 million euros in cash per year. So that's quite important for us. So MIAI in a few numbers. So we are basically organized into 2 main areas, one which is at the core of AI and at the core of MIAI. I will explain the slight difference between the core of AI and the core of MIAI, and some applications. And the main applications we have are on health, environment and energy, and Industry 4.0. This does not mean that we exclude the other application areas. On the contrary, we are willing to develop them, but these are the main ones, the most structured ones. And this, of course, will evolve, even though our motto is AI for the human beings and the environment, and that's something we want to continue to develop. So in terms of the core of AI, we are working from both hardware architecture and embedded systems for AI or using AI to software and to axes like machine learning and reasoning, perception and interaction, including computer vision, natural language processing, speech processing, robotics, and also which is something that is maybe not an exception, but that is quite developed in our institute, is an axis around AI and society. And this axis of AI and society, if we place it in the core of AI, it's because here again, AI is the subject of study. That is, in all these directions, AI is a subject of study. And so in this axis, AI and society, we have colleagues from sociology, colleagues from philosophy, from legal studies working with us in order to develop the framework of AI, the different possible regulations of AI, and better understand the usages of AI. So this is quite a differentiator, and the fact that we work on this continuum from hardware architecture to software systems is also a differentiator, in particular on the hardware part. So you see that in a bit more than 2 years, because we have not updated these numbers yet this year, we have more than 600 publications, around 230 permanent academic members are involved, 125 PhD students, 40 postdoctoral researchers, and this has increased also. Around 30 chairs, 16 exploratory projects, which are, so chairs in MIAI are large projects. They gather around 5-6 permanent members, approximately the same number of non-permanent people. And so you see it's quite a large project with ambitious research goals. And so we have fewer chairs than the other AI institutes, but they are larger scale, and the perimeter is larger. And so we wanted to have that, to also have the critical mass in order to achieve our goals. And we have a few other projects which are typically less large, with 1 or 2 permanent members, sometimes 3, and 1 or 2 non-permanent members. And we have a certain number of projects which are here to develop new areas around AI. And these are just the research projects, but I want to mention that we also have 150 collaborative projects with our partners. And these are projects, most of them are projects, are research projects, both fundamental and applied. Okay, so I mentioned that if we take all the investment from the private partner, it's around 22 million euros for this period of 4 years, this first phase of our institute, with around a bit more than that, in fact, and a certain number of patents, a certain number of software, and as you can see, a certain number of startups that were created, and 11 more which are in the pipeline. So here I want to say that MIAI is relying on all the actors, be it in terms of research, in terms of education, in terms of innovation. We are relying on all the partners that exist on the site. We have not created any new structure, but simply have created a place where they can gather and discuss AI subjects and try to improve the momentum on this one. And so the work of the Innovation Board is quite important here. So the SATT Linxium, CEA, Inria, Floralis, INPSA, and so as you can know, they are all members of our Innovation Board, and they all work together in order to develop our impact on innovation. We also have created 2 joint public-private labs and contributed to the fact that big companies have decided to establish their AI department in Grenoble. And the fact that MIAI was in Grenoble was key for this decision. Okay, so in terms of education, so there will be a session dedicated to education this afternoon. This will be chaired by Jean-Louis Roch, whom Yassine mentioned, who is the head of the education board. And so, I mean, in 2 years, we have been able to, we were created in 2019. So in 2 years, we were able to double the number of persons trained in AI. And this was possible due to two main actions. The first one was to increase the offer on AI, and this was done by creating new courses, but mostly by integrating AI in existing courses. And the second action was the creation of labels. A label application of AI and the label core AI. And these labels are given to syllabuses. So for the moment, we have 14 syllabuses which are labeled core AI, 19 syllabuses which are labeled applications of AI. So on different aspects, it's not only computer science and mathematics. There are syllabuses, of course, in health, in geology, in I think in innovation as well. So you can see it's quite large. And then any student who is following these syllabuses which have been labeled as a label at the end, a label given by MIAI. And as Yassine mentioned, recently we were able to secure a bit more than 6 million euros for our education activity, part of what the French government called the massification of AI. So, and the will here is to try to train people at different levels, including collège and lycée, I will say it in French, collège and lycée in France. Okay, and I need to be a bit quick. So regarding international collaborations, so we first, I mean, I think like it's a reasonable plan to follow. We first try to establish ourselves in Grenoble, in the Aura region, then in France, and we are trying to develop our international activities and international collaborations. Of course, there are a lot of collaborations between researchers internationally. That's part of the current activity of the daily activity of researchers. And so we are part of 4 European networks, including 2 networks of excellence centers in AI. We are trying to create an ELIS unit. Won't spend too much time on that. We have several large international projects. We have created a joint AI center with Swansea University, and we're discussing with centers in Canada and in Japan. And as I mentioned, there are many point-to-point international collaborations. Okay, so let me be quick. An important point of our activity is to try to make people gather and discuss. And there are so many things happening in AI that it's not possible for an individual, even for a small team, to follow everything that is relevant for a person or a team's activity. So it's very important that we have places where people can discuss and filter out what is not really relevant for them and what may be relevant for them. And so, as you see, there are a lot of meetings organized. Maybe too many for a single individual to follow, but that, as I said, it's very important, and we have been able to maintain monthly meetings right from the beginning with around at least 50 persons per meeting, which is quite nice. It's a bit difficult in terms of sustainability in time, I would say. Okay, and to conclude, just a few elements. There's a lot of information on our website. We regularly post. When I say we, it's Manel and Snejana who are here today. They regularly post on Twitter, on LinkedIn, and we have a YouTube channel that you can visit, which contains a lot of interesting elements. So thank you, everybody. I just want to conclude by thanking Snejana Benvenuti and Manel Boumegoura, who were the chief organizers of this event and of many events we have. And so please join me in thanking them. Okay, so I propose we step forward into the next session. And so this will be a keynote session with 2 speakers. The first one being Claude Castelluccia. So it's a pleasure to have Claude. I remember having invited him once to give a keynote speech in the lab I was directing at the time. And Claude is a research director at Inria Grenoble and a founding member of the Privatix group. And since August 2021, he's privacy commissioner at the French Data Protection Agency, CNIL, la Commission nationale informatique et liberté, in charge of new technologies, digital administration, research, and statistics. So Claude is well known for his work in data privacy, in security, and machine learning privacy, data anonymization, and more generally, privacy-preserving systems. And it's really a pleasure to have him here today. And he asked me whether he could be accompanied for this keynote speech with Alexis Léautier, who is a technology expert at CNIL. Alexis is specialized in the issues that artificial intelligence raises regarding privacy protection. And relying on his previous experience in the fields of robotics and smart meters, he contributes to building the CNIL's doctrine on artificial intelligence. So if I understand correctly, Claude is going to give the first part of the keynote, then he will leave the floor to Alexis Léautier, who was not able to join us today because of the strike, but who is connected via Zoom. Claude, the floor is yours. Thank you very much.
Thank you very much for the introduction, and thanks for the invitation. I'm very honored to be here today and give this talk. I will give it in English because apparently there are some non-French-speaking people in the room. So I will give this talk together with Alexis. As Eric said, I'll try to talk for half an hour, but we're already late, so we might be even later. And Alexis will also give a talk for half an hour. So I thought it would be a nice idea to have someone from the CNIL giving a bit some of the official position of the CNIL on this topic. So it will be about machine learning and privacy. As Eric said, I'm a senior research director at Inria, part of the Privatix group, that is a group working on privacy. And I'm also a privacy commissioner in charge of new technology and specifically of AI. And our goal there is basically try to regulate the usage of these new AI technologies. But just as a very important disclaimer, the view and opinion expressed in this talk are my own and do not necessarily reflect the views of and position of the CNIL or, as a matter of fact, of Inria. My talk is basically, machine learning and privacy. We see that there are more and more machine learning systems that are using and trained using personal data. And a very specific application for that at what we call the algorithmic decision systems, so the systems that are used by humans to help making decisions. So there are many different examples that you might have heard of, like the predictive justice system that try to give a score to people that got arrested in order to decide whether they need to go to jail or not. There are systems developed for health, systems like facial recognition or smart video that are also being deployed for different types of applications. So the combination of personal data and machine learning, it's a growing field, and it creates a lot of issues, in particular privacy issues. And I will try to tackle some of them, but because we don't have much time, of course, it's not exhaustive. Just to quickly give a quick overview of this algorithmic decision systems, so systems that are mixing machine learning and personal data. There are different ways of categorizing them. But there's one way that I like, is the one proposed by Arvind Narayanan, who basically said that you have systems that try to automate analysis or task, typically facial recognition. You have some task and you use machine learning to train it. You have other systems that are there in order to automate judgment. You want to make a judgment, like whether this is a spam or whether this is hate speech. And the third category are systems that are trying to predict the future, basically predict social outcomes. And if you look at the performance of these systems, the first one are quite good. They provide good performance. Like facial recognition are getting more and more accurate. The second one, which are trying to automate judgment, are also improving. They are sometimes making mistakes, but they are improving. But the third category, the one that is trying to predict the future, is really, I mean, there are like very doubt about the scientific background of the system. So they are fundamentally dubious, like predicting whether someone will commit a crime or predicting the job performance of someone is kind of worrying, or I mean, we're not sure that it's actually something that really makes sense. So those three different systems actually creates ethical concerns for different reasons. The first one are concerning because they are very accurate. So just think about facial recognition. There is some kind of agreement that video protection is accepted because we know that they're not super efficient. Now, if you go and use facial recognition instead of video protection, you will get something that is very accurate, and that creates ethical concern. The other one, the one that automate judgment, create also ethical concern because they make sometimes some mistake, and we don't know in which case they're making those mistakes. And the third one are probably the one that are creating the largest, biggest ethical concern. It's because it's very often based, as I said, based on pseudoscience, and they are highly inaccurate. So as a matter of fact, as the system are shaping our world, we think that it's very important to regulate them and think about their limitations. And in particular, and that will be the scope of this talk, we think it's important to evaluate the performance and limitation of the system, but also to evaluate the security, privacy, and robustness. It's like having a car, you know, when you deploy a car, you're not going to deploy it without brakes. For machine learning, it's the same thing. It doesn't make sense to have a research, for example, institute without any activity on security of machine learning, because they won't be deployed. I mean, you're not going to deploy something that is not secure and robust against adversarial attacks or robust against some failures. So if we consider one piece of regulation, which is the GDPR, although it's not the only regulation that applies to AI, I mean, there are a lot of discussion at the moment at the EU level on the new AI Act that will regulate usage of AI. But GDPR, of course, is also a piece that needs to be applied because, as I said, this system are using personal data. So I'm not going to give a class on GDPR because it would take a lot of time, but basically when you have to consider GDPR, you have to look at the purpose limitation. So you deploy a system only for a specific purpose. You have to minimize the data that is being used. You have to have some legal ground. You have to check the performance because you only deploy it for a specific purpose. So you have to make sure that your system is going to fulfill the objective of your system. There is data conservation. Security, it's a big piece. You have to make sure that the system is secure and private, does not leak any personal data. And then you have the user right. You have to provide the right to the users. So we will basically try to tackle two of these issues. So I will talk about performance, and then Alexis will say some words about the security aspect of the systems. So performance, evaluating, once again, a machine learning system or a algorithmic decision system, it's actually required by the GDPR because, once again, you have to prove whenever you deploy a system that the performance actually are good enough in order to fulfill the purpose of the system, right? I mean, you do not deploy the system just for the fun of it. You have somehow to prove that it actually fulfill the goals. And so the GDPR has this concept of privacy by design. So by design, you have to think about how to embed privacy from the beginning. I think we should have something similar for evaluation. We should have something like evaluation by design. So from the beginning, whenever you design a system, think about how you're going to evaluate it. And that might actually require to collect a bit more data, which might go against the data minimization of the GDPR principle, but still it's very important, right? Evaluation is actually a key component of the deployment of machine learning. So how do you evaluate a machine learning system? Technically, there are many different ways, and I'm sure the one who are working here, who are working in machine learning knows that you can measure the false positive rate, false negative, accuracy, and so on. But it's not enough. We realize that even if you have systems that provide technically good performance, they fail whenever you deploy them. And it's very important to understand in which cases they actually fail, what are the limitations of the systems. So there are many sources of failures. And typically, they can be classified in 4 categories. There are some systems that fail because they're just trying to automate some impossible task. Impossible because this is conceptually impossible or because the data are just not available. That's the first category. The second reason is that there are some failures in the engineering process. Implementing a machine learning system is very complex. You have a lot of parameters to choose, a lot of tuning, and it's very easy to make small mistakes that will just invalidate the results of your system. The third categories are due to post-deployment failure. So you are developing your system in a lab, and then you deploy it, but it's not exactly the same environment. You're not using the same cameras, or the environment is not the same. There's the lightning is different. And as a matter of fact, your system will just fail. And the third category is what we call AI hype. People tend to oversell the performance of the result, either because they want to publish a paper or because they want to sell a product, and there's a huge business into machine learning, as you know. So I try to give some example of each of these categories to make it maybe clearer. So the first one is basically systems that the tasks are just impossible. We know that it doesn't make sense scientifically, but still there are some people trying to do it. A good example, I don't know if you know this example, but a few years ago, there is a group, I think it was in China, that pretended that they designed the perfect criminal machine. And the system basically says that given a photo of someone, they can tell whether this person is a criminal or not, or whether he will commit a crime or not. And actually, the system had a very high accuracy. It was actually amazing. Like the accuracy was around 90%. And so what can we conclude? Can we conclude that there are some physical feature in the face of people that can be used to identify criminals? Is it the nose? Do they have like bigger nose than the average, or is it the eyes on the ears? I mean, usually I ask the people what they think, what's the mistake, but because I don't have time, I will just give you what happened. So basically, what they just did, and I don't know if you know this study, there's some other paper that shows that they just actually created a smile detector because the data was just biased in the way they trained the system. They basically got photos from criminals that were people that were just arrested. So usually when you're arrested, you're not very happy. And the other one were people that were photos from collected from social network or photos from identity cards where you tend to look good or smile. And the system was just looking whether you were smiling or not, and it ended up to basically provide very good accuracy. And so, we all know that correlation is not enough. You need to show causality, but there are a lot of systems, and since it's difficult actually to show this causality, there are a lot of systems that are just deployed and they are just bogus, right? Actually, there is a site that is called Calling It Bullshit. I don't know if you know this site. It's a great site that gives a lot of examples about systems that are deployed and they are just based on bullshit scientific background. And it's very important to detect and know those systems. The second type of mistake could be due to the fact that the engineers or researchers are just making small mistakes in the way they design the system. They use the wrong parameters or the wrong data set. A quick example, facial recognition, as I said, they are getting very, very accurate. The NIST is evaluating regularly facial recognition systems, and there are some systems that have an accuracy of 90.5%. If you only have one image of a person in the database, if you have more than one image, the accuracy can be even higher. So those systems technically are very accurate. But, and probably you know these studies, there are some studies that shows that this accuracy varies from one group of individual to the other one. So some studies that shows that the system perform much better on white males than black females, right? And the difference in accuracy can be quite huge. So the study that is quite old, I guess now I'm sure that the performance are better, but at that time there were like 35% of errors for dark-skinned female. And once again, the question is that, does it mean that those systems are racist or misogynist? And the answer is, of course not, right? I mean, those are just system algorithms. It's just in the way that the data was collected, right? There was some bias in the way that the data was sampled and collected. So you might think, okay, this is easy, right? I mean, there's just a bias. We will try to fix it in the data set. I think there will be a session on bias after my talk. But it's actually a very difficult topic, very difficult issue, because, I mean, if you try to understand the different sources of biases, there are many sources of biases in our life, or in the way you actually build machine learning. You could have bias, what it's called historical bias. So, like typically, nurses are more often associated to females and engineers to males. So that's part of our society. So if you just collect the data, this bias will, of course, be part of your training data, and most likely your algorithm will amplify this bias. This is part of our society. There could be biases that are due to the fact that you are sampling the data, right? And a good example is the example I gave on facial recognition. Most likely, the system were designed by a researcher I guess, in California, and they tend to have more faces of white males than the dark-skinned females. That's just a mistake in the way they sample. They got the data from their source. And you can also have bias on the metrics that you use in order to evaluate your system. Like, for example, if you try to measure the criminality in the area and you use the number of arrests as a metric, it will be highly biased because you will have more arrests in areas where there's a lot of police, typically in minorities areas. There are more police, so it will most likely lead in more arrest, which will give the impression that the criminality is higher, which might be the case, but still you have this bias on the fact that because you are collecting more data in these areas, you will introduce this bias in the system. So there are many different sources. Those are only 3 examples of bias that you can introduce. And although it might seem like a very easy problem, technically it's quite difficult. Of course, we should also go beyond biases and think about labeling, how those data are being labeled. And so there was a paper that was published a few years ago where they study a large data set, typically large data set that are used by the research communities. And they took the example of ImageNet, that is a huge data set used by most researchers working on image processing. And they realized that there are mistakes in this data set, right? Some data were just incorrectly labeled, or was approximative or offensive labels. Typically, they are labeled like a child wearing sunglasses is classified as a failure, loser, non-starter, unsuccessful person, right? I mean, we don't know how this label came up, but there are a lot of mistakes like that. And because these data are usually used, I mean, mostly used by all researchers in the community, they will just propagate in all research papers or results. So we have to be very careful about how these system labels are done. I mean, we should also realize that labeling is normative. The way that we define the label it is according to a norm. Like in this paper, they give the example of gender. Usually, labeling consider only two gender, which is male and female. They don't consider alternative genders, which might be, I mean, the case, right? So there are a lot of decisions that is made about how you choose the label, and you make labeling that is really normative, and it's quite political. So there are a lot of questions around labeling about how you should label the data, who should decide how does labeling should be performed, and how you should measure somehow the accuracy of these labels. So this is actually quite tricky. It's not only technical, it's also a lot of sociology and I guess legal aspect about labeling. The third type of categories is the fact that sometimes you develop a system in a lab and then you deploy it out there, and it's not exactly the same environment, the same equipment, so you end up having systems that do not perform as they are supposed to do. A good example is the Uber self-driving experiment, where they released it, and then there was the car just struck someone that was pushing crossing the road with a bicycle, and because the person was not crossing the road on the crosswalk, the system did not see it because it was associating. I mean, for the system, people that are crossing the road were necessarily crossing it on a crosswalk. And if it was not the case, this is what happened. The person was just crossing and the car just didn't stop. So that's an example of things that you deploy it in the lab and then you use it outside. Sorry, you develop it in the lab, you deploy it outside, and the environment is different and you are missing some of cases. So those examples are sometimes called adversarial examples. And the fourth one, which are just what I said, I would just keep it, is AI app, people trying to oversell their product. Good examples are the systems that are pretending to be able to assess the personality of a person with a 30-second video. I mean, this is more and more used when companies are trying to recruit new people. They ask you just to send a 30-second video, and then from that, they try to extract your personality. This is just bogus, part of what it's often called AI hype. So there are many, as I show, I guess, sources of failure. But something that we should not forget is sometimes the failure are just the humans, right? And very often we just forget that those systems, especially the algorithm decision system, are used by humans, and sometimes the humans are making mistakes. So, for example, the operators are just not using the right format in a facial recognition system, or the quality is not good enough, or they tend to overtrust the systems. Like this is what is called automation bias. I don't have to talk about there was a Dutch childcare benefits scandal where a lot of people got into trouble because the system were flagging them as people that were doing fraud, and it was just due to the fact that the operator were just following the prediction of the system and were over-trusting the system. And there are other cases where the operator do not use this algorithm decision system, or do not follow the recommendation because they don't trust them. So it's also important to consider in this type of system that they are not only technical systems, they are social technical systems, and whenever we evaluate them, we should not only evaluate the technical part of it, like only the machine learning accuracy, but we should evaluate the whole system together with the human and the environment. And it ends up to be very difficult. I mean, how do you actually evaluate a system? What kind of metrics should we use? It's actually much more difficult than just evaluating some kind of machine learning algorithm in a lab, which is already difficult. So I don't know how much time I have, so I think I would have to stop on my part. Some short conclusion on my aspect. I think it's worrying to see that there are those systems deployed without full evaluation. The other part of building a machine learning system is not to build a model, but is to assemble the data, validating the model, evaluating the performance, evaluating the impact on humans and human rights, integrating it into existing workflow, and adding oversight. Make sure that you are always looking at the performance of the system while they are running. So they really, and this is a call to the research community, there is a need really to define some rigorous evaluation methodology. By the way, just as a quick side words, there are similar concerns in the research community. And I was quite amazed to see that, so there was a paper that was published in UGA Security last summer. It's one of the best conferences in security. And in security, researchers are more and more using machine learning as a black box, right? So in this paper, what they did is they took the 30 papers in the top conference in security, papers that were using machine learning as a black box, and they realized that all these papers were making some mistakes that were invalidating the results. And quite serious problem, right? Because once again, machine learning are difficult to build, and this is what I tried to show, but they're also very difficult to use. I mean, it's just not a black box that you use like that with input and you get output. You really need to understand what you're doing. And these papers, and this is not, I mean, there are other papers in other fields. I mean, this is not specific to security. I took this example because that's my field, but there are other papers that show that the same trends happen in all research area, and we need to have more awareness on these topics. You know, a lot of papers that are published are just bogus because the machine learning module were not used correctly. So this is quite concerning about research integrity. Some final remarks. I just want to finish by saying that, give some positive remarks about this algorithm decision system. I think they are great. I mean, I don't want to give the impression that I'm against this machine learning system or algorithmic decision system. They are very great in some areas, like for medical care. I mean, there are some studies that show they are very good at detecting some kind of type of cancers, and sometimes better than some medical doctors. But we just have to be careful about what we are deploying and how we are deploying it. And also, another remark is that, are human decisions better? I mean, we sometimes think that human decisions are better than decisions made by algorithmic, and that we don't have any biases. This is, of course, wrong and incorrect. So there is these studies, I don't know if you know these studies, but it shows here the number of positive or favorable decision of a judge according to the time of the day. And it shows that, you know, a judge tends to have like positive judgment early in the morning, and then it goes down until there is a break. Then he gets some coffee, and it goes back again. So there are like some bias due to the way people think. So biases are everywhere. They are in algorithms, but they are in humans. So we just have to find a way to combine both systems in a way that we get the best of both of them. I guess I'm done for my part. I'll give now the floor to Alexis. I don't know if Alexis, you're here.
I don't know if you can hear me.
Yes, we can.
Perfect. So just let me share my screen and my camera. Okay. Looks like it's working on my side, but I'm not sure on yours. Can you see my slides?
Not yet, but...
Yes.
No, I think that's still my slide.
Only online, perhaps.
Yes, online we see them.
Okay. Okay, c'est bon. It's good way, I see.
Okay, perfect. So thank you very much for having me, and I'm really sorry about not being here in physically because of the strike, but thank you for having me online. So I'll dive directly into the subject because I understand that we have quite strong time constraints. So this talk will focus more on the principles, risks, and tools for compliance that AI and privacy raise. So the subject of AI at the CNIL has been a subject for work for some time now. So we have published several papers, the first one in 2017, a report on the ethical issues of algorithms and AI, a second one in 2020 on algorithms preventing the automation of discriminations linked with the Défenseur des droits, another authority in France. In September 2020, we published a white paper on voice assistants, and in 2022, a position paper on smart and augmented cameras in the public space. So we have been working on this subject for some time now, and we are trying to even accelerate this work because we receive more and more projects that use AI and that raise specific questions that we haven't been able to answer until now. So those projects use smart video, decision aid in medical and diagnosis or in hiring processes. So all kind of sectors. And we receive questions such as, how do the main principles of the GDPR apply? What obligations apply to data controllers? And how to ensure the rights of data subjects, how to ensure that they are respected. And finally, in April 2021, a proposal for an AI regulation was published by the European Commission, and it forbids, for starters, the use of certain AI systems, such as the use of biometric identification in certain conditions. It also provides a legal framework for putting high-risk AI systems on the market. And finally, it states that a supervisory authority should be appointed. And with regard to this possibility, the CNIL takes a stand. So since the beginning of the year, we published a list of papers and articles online that are aimed to all kinds of public. For starters, the general public, more privacy professionals, and finally, specialists of AI. So the main part of those articles are on the website of the CNIL, but some of them are more on the link website, which is the innovation laboratory of the CNIL. The goal of these publications is to provide visibility for the CNIL with respect to this role of supervisory authority that is raised by the proposal of the European Commission. We also aim to promote good practices and to increase legal certainty, because we understand that making AI compliant today with the GDPR is not straightforward. So I invite you to go on the website and maybe dive more in detail in all those publications. And we aim, of course, to publish more and more publications, and most of them should be doctrinal now. So that means that we are trying to publish useful and how can I say this? The publications that can be used by data controllers in order to make the AI systems compliant. So in this second part, I'll dive more into the dangers that AI raise on privacy, and I'll try to go quite fast. So for starters, we have the usual risks, of course, the loss of confidentiality, integrity, or availability of the data. especially the data that's used to train the AI systems, but also the data that's used in the production phase. And the dangers we meet today are from human or non-human causes, and they can come from inside the system or from external causes. The second kind of attacks that we meet are more specific to AI, and we have the manipulation attacks that aim to change the whole behavior of the system by using specific inputs. Secondly, we have infection attacks. The goal of those is to have a selective modification of this system and its behavior in specific conditions. And finally, exfiltration of the model or of data linked with the AI system. And I'll dive more into this kind of attack because it's the one that's mostly linked with data protection. So let me go right to exfiltration. Yes. So the first kind of those is membership inference attacks. And the goal is of this kind of attack is to get knowledge on the presence of a data point or a person in the training set. So we have access to some parts of the AI system, not necessarily the parameters, but generally at least the outputs and maybe the confidence score of the system. And we see today, especially in the academic literature, that it's possible to infer some attributes or to infer certain information on data subjects that were present in the training set. And the main cause of this is because those AI systems are subject to overfitting. So this is an example showing that you can retro-engineer the training data from the trained model. It was published in 2015. And so using the outputs and the confidence score in a facial recognition system, the authors were able to retro-engineer in some way the face of a person that was present in the training set. And we can see that we are able to, well, to recognize the person, but it's not perfect yet. But still, it shows that there is a risk to reconstruct training data. Another kind of exfiltration attacks are the model inference attacks. And the goal is to retro-engineer the parameters of the model by having a black box access. And this doesn't raise issues directly related to data protection, but it can enable the other categories of attacks and make them a lot easier. And finally, so the third kind of risks of AI and privacy are the flaws and the performance issues that Claude mostly presented, so related to bias, prediction error, a lack of transparency, model or data drift, and filter bubbles. So the fact that when you're presented with a recommendation system, for instance, you usually end up in a filter bubble, meaning that it only recommends you data that's that you already, well, that is close to your interests. So in order to take those risks into account, the way we at CNIL we approach this issue is that we invite data controllers to perform an analysis of the risks on data protection. And firstly, you have to want to question the severity of the risks. So how many data subjects are they vulnerable? So what could happen to them is the main question you need to ask. And then the likelihood of the risk. So how could it happen? And in order to answer this question, you should ask yourself what means are necessary to conduct the attack. And related to risks on AI systems, we see today that those risks are not really mature yet, and we don't really meet them in practice, but this could happen very quickly. So in the near future, these attacks might become a real threat, and that's why we're trying to tackle them right now. So this is a part on privacy enhancing technologies, but I'll try to go very fast. So the first one we meet is data synthesis, which is very large. It's an umbrella term that can that can be met in practice in several practices. So simulation for starters, the duplication of statistical distribution. So meaning you try to duplicate the statistical distribution of an existing data set. And thirdly, the generation of specific data. And this, we mean by that deep fakes, for example. And in practice, so when you try to generate synthetic data, you try to model the statistical distribution and to generate data that's, that fits this distribution, and you generate either a whole data set or specific data points. So this is an example of an algorithm that can be used to generate data. It's really well known now. It's the generative adversarial networks, and I won't go into details because we don't have time for this. An example of a use case of synthetic data is the one presented by the US Census Bureau. It's called On the Map, and it's a cartography of workplaces and residence locations of American workers. This data presents statistics on the age, earnings, race, ethnicity, educational attainments, and sex of the American workers. And the website tells us that this is synthetic data, but it's based on real data. And so we see on the map that at the moment we aren't able to identify any person, obviously, but if we zoom in, maybe not here, but maybe in some other location, how related to the real data will be the synthetic data that's presented to us? This is still a question for us, and we found very little information on the website presenting the methods used and the actual risks. So synthetic data raises some risks, but also presents some opportunities. It's a possibility for pseudonymization or even anonymization in certain cases that can open the door to open and sharing the data. And it's also a possibility for data generation without any data collection. So this is a real plus for the CNIL because in application of the principle of minimization. And the risks, so mostly we see that there's a huge loss of utility in some cases, meaning that the synthetic data doesn't represent that much the source data, and it's not really as useful as the real data. Concerning the synthetic data, it can also present bias and underrepresent some categories. There is a lack of transparency, especially concerning deepfakes, and there's a risk that isn't really tackled by people who generate data at the moment. That is that when you generate synthetic data, there's a possibility that you could infer some attributes and some information about people, which would be wrong because it's synthetic data. So we don't really know how to tackle this issue at the moment. And it mostly raises issues concerning transparency. So our conclusions is that the use of synthetic data should be a good practice when it replaces the use of the source data set. And in most cases, it should be accompanied by an analysis of the re-identification risks in order to show that the data is anonymous, or at least to measure the risk that it raises for data subjects. Another technology is federated learning, but I think I'll just skip it because I really don't have time. And some other techniques that we consider at the moment, which are differential privacy, the use of trusted execution environments, and another category of technologies that needs, in our perspective, more study are homomorphic encryption and machine unlearning. Finally, so when we want to make an AI system compliant with the GDPR, the CNIL has published some tools and is trying to take a stand on the main principle and how to apply them to AI systems. So as Claude presented, AI system raise a lot of, well, not necessarily issues, but at least questions on how to apply the GDPR and the main principles, which Claude presented. And sorry, so I'll just keep this. In order to answer those questions, the CNIL published a set of articles and documents, and one that can be very useful if you use AI system is the one that we called a self-assessment guide. And so it uses 7 checklists, sorry, that try to tackle the main questions raised by the AI system, but in kind of a chronological order, meaning that we firstly we ask the right questions before using the AI system. Then we tackle the questions related to training data and to pre-processing of the data. Thirdly, we have questions related to the development and the training of the algorithm. Then how to use an AI system in real conditions. 5 checklist is how to secure the processing. In the 6th one, we found questions related to the people's rights and how to make sure that they're respected in practice. And the final one tries to tackle questions on how to comply with obligations raised by the GDPR. So this is presented as a survey, meaning that you have a list of questions to answer. We don't provide the answers you should have, but just the main goal is just to lead you to this process of, well, questioning the AI system, questioning the main ethical issues it could raise, and questioning the main obligations of the GDPR, and leading you to, well, enter into compliance progressively. So of course you can send us the filled-in checklists, but we might not be able to provide you with an answer, but we will be very interested in your returns. So that's it for my presentation, and I hope we have some time for questions now.
Okay, so we have some time for questions. Thank you very much for the timing also. So I don't know whether there's questions online. And there's a question here. Yeah, so I need a mic.
Thank you both for the presentation. My question is, so in the last checklist that you showed, there was ensuring that the user data are protected, or I don't know how you phrase it, but the word was ensuring. When we are talking about this very, very, very complex system, we know that right now the formal verification tools, they don't scale up to this kind of a very complex system. So what kind of insurance can someone provide when they are doing, I don't know, image recognition, or basically processing data that is very, very high dimensional, where the tools just simply don't scale up and you can't prove anything except on perhaps a synthetic data, and even then. So would proving a system using synthetic data be acceptable in terms of GDPR? And well, thank you.
So Claude, I think this question is directed to me, so I'll just take it. So ensuring, the word was used, I think, related to people's rights and not the security of people's data. When it comes to people's rights, there is a way, well, the obligations that are brought by the GDPR are very clear, and there is a way of ensuring them. There is a way of ensuring that people can use their rights to be forgotten, the right to access, the right to, so all the rights brought by the GDPR. But I agree that related to the security of the data, it's very hard to find ways, formal guarantees of the security of the data. It really doesn't exist at the moment in most cases, and we see it's not even related to AI systems, but in general, there's a lot of attacks that we see today. Even this morning, I heard an attack on another hospital in Versailles. So obviously, the security of the data is never ensured, and you can, well, all you can do is just try your best to make that it's secure and follow the guidelines that the CNIL publishes and other agencies such as the NC, which provide guidelines on several aspects of security of data.
Thank you.
I mean, just to add a word, it's really a risk-based approach, right? You're trying to evaluate the risk and do the best according to the state of the art. But you're right. I mean, there is clearly here a need to build auditing tools or to build tools in order to verify the property or to verify the security performance of the system. And this is also why we're here today. That's a call to the community. Please help us developing this tool, developing this methodology. It's very challenging. As a matter of fact, we have a project at the moment at the CNIL on the usage of data for machine learning. So we are at the moment discussing with a lot of actors from research startup companies about how they use data to build machine learning system. We will publish some recommendation, and there will be a consultation phase. And so if you have anything to say, if you have any specific need, it's the time to come and contact us and talk to us about it. But once again, it's I mean, we also, like you, we're learning, and we need the help of everybody at this stage.
Other questions? Yes.
Yes, this is also a question for Alexis related to the data synthesis aspect. So it may not be a question totally, but it's rather, you should take it as a cursor point to do data synthesis, because the problem with all the constraints that you put on data synthesis, if you are able to generate a data that is still relevant, that it's still representative, that is unbiased, etc., you have a very good model of what you're looking at, and you don't really need machine learning anymore. Okay, so that was my thinking about what you say.
Yes, so just to maybe not answer, but just going forward, indeed, that's something we see, that if you try to model your source data perfectly, obviously you might have answered the question you're trying to resolve with the synthetic data. So it's kind of the snake biting its own tail. But what we're trying to, well, the issue we're trying to raise is that when you use synthetic data, well, it might not be, well, relevant to your use case, but if it is, synthetic data can present data that was in the source data set, and there are risks linked to re-identification, or synthetic data could not be, well, anonymous in the end. That's our main point.
But yeah, if I can say a word, I mean, for me, synthetic data, it's one way of generating anonymized data, right? It's just a different way. But I'm not sure I understood your point, because the goal of synthetic data or anonymizing data is to make sure that you're not leaking any information about any particular individual in the data set, right? But you still want to keep the statistical property of your data set. And so I'm not sure I understood you. I mean, like, if you want to train a facial recognition system, you might be able to train it on synthetic data, right? And you use it to actually build another model. So maybe I missed something on your remark, but I still think that they are useful, although it's difficult to generate them, and it doesn't solve everything. But
another question here. Snejana, if there are questions online, can you just tell me? Oh, no, we go ahead. I don't know whether there are questions online.
Okay, just a devil's advocate question. So I'm a sociologist, and thank you, Claude, and thank you also for your both presentation. It was really fascinating. At some point you said there is an issue with an ADS that is telling us that someone is a criminal or not. And you said, of course, the technology is not racist. It's the data set that contains some biases, et cetera, et cetera. So my question would be, isn't it time, perhaps, if we want to consider AI and ADS as socio-technical system, to assume that a technical system can be racist? Isn't it perhaps time to introduce ideology into those types of systems and see that there is structural racism, for instance, that has nothing to do with the fact that you act racistly, but you have prejudices. So it's kind of a question that I'm asking myself, but both of you too.
Yeah, I mean, that's a good question. But I mean, what I meant is that the algorithm is not racist. The generated model might be racist or might have behavior that are racist, but the algorithm, the learning algorithm by itself, is not racist. Doesn't know what it is doing, actually. You just feed it with data in generating a model, and then you can have a model that has behavior that are racist. But it's not inherent to the algorithm. I mean, because they're just stupid things, the algorithm that are, building with the data that you feed. So the data might be racist. The bias on the data might have some racist behavior, but at the end, the algorithm, you cannot blame the algorithm for that, right? You can blame the data, or you can.
The judge would say that the algorithm is an accomplice of the racist structure behind the accomplice.
Sorry, I didn't understand. Maybe the judge would say.
Would consider perhaps that you are accomplice of the racist thing that is behind the algorithm if you do not see it.
Okay, so you.
The law, if you don't see a crime and you don't report it to the police.
Right. So now you're talking about the person that are developing a model, right? And you're not talking about the algorithm. I mean, if you consider the algorithm as a piece of code, it's not racist. I mean, you cannot. I mean, just in the way you actually. But I mean, those are. I mean, we can be very happy to discuss with you on that during the break. But
okay. Other questions? Okay, maybe one last question for you, Claude, before the break. So I no longer present those systems are automated decision systems, but rather are decision aid systems. And this changes slightly the way you look at them and the way you envisage their usage. And in the sense that I fully agree with you that the usage is important and that we need to take into account the context in which they are going to be used, even for developing and evaluating them. But I believe this is done by many, in many contexts. There are a lot of industrial partners of MIAI who are doing that, in fact, and using those systems with this evaluation. And if you look at them in terms of decision-aid systems, then it's not the humans versus the system, but it's both of them together, as you said at the end, right from the beginning. And so my question remark was, I mean, some people made us believe that we will be able to fully rely on those systems, like this fully automated car, which I think it's no longer on the plan right now. And but if you change your mind, change the way you believe in them, you see them, then you see that okay, they are just a tool like any digital device. And to a certain extent, I was wondering whether all the conclusions you mentioned were not applicable to all digital systems and not only to AI systems.
Yeah, I mean, the algorithm decision system is actually a generic term, and I didn't have time to go through the details, but there are, as you said, different categories. There are systems, what you call decision head system, that you have the algorithm that help you taking the decision, like visualization tools. Right, that's one category. Like doctors, basically, they have some tools that help them analyzing. You have systems that make recommendation, and then the human decide to follow or not. Yeah. You have systems that make recommendation, and the human follow just the recommendation or might decide to not follow. Yeah. And then you have fully automated system, but they have like different, I will say, shade of algorithm decision system. And
yes, but even in this case, they are just tools. To help people, like a driving aid, for example.
Yeah, but if you have like autonomous weapon or cars, they are not tools.
Yes, but I think the
maybe what you're saying is that we won't never be able to do it. Although there are some drones that are already being used to kill people without any human intervention, right? So it's one possible trend, but.
No, I'm just saying, okay, the autonomous car is a good example. I think it was an example that was given, but which is a marginal example. And it does not exist despite yet. I'm not sure it will exist. I mean, we can try, and I agree with you. I mean, okay, there are tools we can make. I mean, I'm saying we should view them as decision-aid systems, even though they can make decisions on their own. It's not what was my point, but we should view them as decision-aid systems, and it changes the way they're used.
I agree, but we should also make sure that this is the way it's used.
Yeah.
I mean, there was this scandal in Netherlands where the system was just flagging people that were doing fraud, and they were automatically fined. You know, there were no human intervention, although they were not supposed to be used that way. And if you look around, and that's the risk, right? Because it's much easier. And then you have like what is called automation bias, but I'm sure Gilles knows more of that about automation bias than I do. People just follow because they're just easier or just lazy, or because if you go against the recommendation, you have to provide good arguments, right? So it's just easier to say, okay, I follow. If there's something, I would just blame the algorithm, you know. But there is this tendency. I agree. I mean, but it's still have to be evaluated, controlled, and we need like strong oversight.
Definitely. But and so my question about the fact that this is not proper. This is not specific to AI, but it's true for almost.
I mean, you're right. I mean, tools, I agree. The only difference is that AI are built using data. And they are less transparent. Maybe we understand less how they work. So you have like things that are specific to this, right? To AI. But you're right. I mean, a lot of discussion about the ethics of AI can be applied to any algorithm.
Yeah, I think so. Okay, thank you very much. Thank you very much again. Thank you, Alexis.
Thank you,
Claude.
Thank you very much.
Thank you, Alexis.
So we have a break till 11, and then we resume with a session dedicated to AI and society.